All right, so I'm going to go over worksheet 52 here. I apologize for getting this posted a little bit late. Hopefully this is of some help as we get ready for the test tomorrow. So, again, we got to graph the pre-image, perform each of the 4 transformations, identify all the coordinates, and write down the rule. Another thing that I forgot to put here, which I'll mention before the test, is label all points on the graph, right? If you hear crinkling, that's just my dog playing with a toy at the wrong time. Kimmy, wrong time. No, right now. Okay, sorry. Anyway, let's go ahead. I'm going to graph my pre-image here. That's going to be triangle number 1. You don't have to number them as long as you label all the points, but I number them just so I can keep track of what I'm doing. Just like that. So I'm going to do number 1 in pencil. Right, J is -1, comma 1, right there. K is -4, comma 4, up there. K, J, and then L is -4, comma 1. There's L right there. So we've got a nice tiny little triangle. It's not going to stay tiny for long because our first transformation here is a dilation. Dilation. We're going to dilate this by a scale factor of 2. So the rule that we're going to use here is x times 2, comma, y times 2. We talked about this in class. Right? So we just take all these points, -1, comma 1. We're going to multiply that by 2. We get -2, comma 2. K prime. We start with K at -4, comma 4. If we multiply both of those by 2, we get -8, comma 8. And when we multiply L by 2, we get -8, comma 2. Just like that. Let's go ahead and plot those points. -2, 2. There's J prime. It's on our pre-image triangle, but that's okay. -8, comma 4, 5, 6, 7, 8. There's K prime. And -8, comma 1, 2. There's our L prime. Do I have a ruler? Oh, I do have a ruler. Definitely want to use your ruler to connect all these points. I don't want to see any wonky triangles. All right, make sure they're all nice and straight. And there's our first image after a dilation. Now we're going to go ahead and rotate it. All right, next is going to be a rotation, 90 degrees clockwise. Using our notes, we know that 90 degrees clockwise gives us the rule y, comma, -x. So what we're going to do, right, here's my x's, here's my y's. We're going to use our prime points. We're not going to go back to our original points. Those points are dead to us now. We don't need to look at those. We're going to take our most recent points. We're going to take all the y coordinates and we're going to bring them out in front. So 2, 8, 2, those are going to get brought into the front. 2, 8, 2. And we're not going to change those at all. Now our x coordinates, those are going to get brought to the back, but we are going to flip the signs, right? When we see that negative in front of the x in our rule, we know that we need to flip all these signs. So -2 becomes +2, -8 becomes +8, and -8 again becomes +8 again. So without even using my transparent slide, I can go ahead and graph this next image, 2, 2, 8, 8, and 2, 8. Just like that. 2, 8, that was L double prime. 2, 2 was J double prime. And 8, 8 was K double prime. Again, we get our ruler. Connect all those up. Boom. Just like that. Now we still have the same size triangle as our first image here. But we did tilt it a little bit, right? We turned it. That's what that rotation there did. All right, there's our second transformation done. I'm going to put that should have been number 3. This one here was number 2. And my original triangle here, that was number 1. And this one, sorry, it looks like a 2. I meant to write 3. Now we're going to do number 4. We're going to translate this triangle 2 units to the right and 12 units down. So the rule here, 2 units to the right, That's going to give us x plus 2. If it said left, we'd write minus. And 12 units down gives us y minus 12. Now, if we were going up, we would add, right? So now we're going to take these green x values. We're not going to go back to the purple. We're not going to go back to the original. We're going to use our most recent set of points. We're going to add 2 to all of our x's, right? So 2 plus 2 gives us 4. 8 plus 2 gives us 10. And 2 plus 2 gives us 4 again. Now we're going to take all these y values and we're going to subtract 12. So 2 minus 12 gives us negative 10. 8 minus 12 gives us negative 4. And 8 minus 12 again gives us negative 4 again. Now we can plot these points. 4 minus 10. 10 minus 4. And 4 minus 4. L triple prime. This one here was K triple prime. And down here is J triple prime. We're going to connect. Sorry, that's my dog. We're going to connect all 3 of those up, and there we go. There's our new triangle. So we translated this one to the right and down. That's exactly what our rule says we're supposed to do, is go right and down. Now we're going to reflect across the y-axis. I'm going to highlight my y-axis. I apologize for the squeaks. Here's my y-axis, and I'm going to reflect this triangle over to the other side of that axis using the rule negative x comma y. Right? When we flip over the y-axis, we change the sign of our x. If we were to flip over the x-axis, we'd have the same rule here, but instead of minus x, it would be minus y. All right? So, again, we're going to take these orange points because they're our most recent. We're not going to go back to our old points. We're going to start right here. We're going to make all of our x's negative. So 4, 10, and 4 turn into negative 4, negative 10, and negative 4. All my y values, though, we're not going to flip those. See how there's no minus sign in front of the y? We're just going to rewrite those right down here. Negative 10, negative 4, negative 4. And we're going to plot those points. There's negative 4, negative 10, negative 10, negative 4. And negative 4, negative 4. L quadruple prime, K quadruple prime, and J quadruple prime. Connect the dots. And there's my 5th and final, forgot to number this one, my 5th and final triangle right here in quadrant 3. So for each of these problems, you should see that we have a triangle in all 4 of the quadrants and 2 triangles in whatever quadrant we had our dilation. Because remember, we're dilating around the origin, right? So we're not going to flip or we're not going to move it or turn it or anything. It's going to stay in the same spot. It's just going to shrink up or expand. If you need to go back to any of that, go ahead and rewind, pause where you need to, do all that good stuff, but I'm going to move on to number 2. And as we go through this, I'm going to get a little bit faster as we move on, just because you should be picking up on what I'm putting down. We're going to start with the pre-image. M is at 10, negative 8. That's way down here. M. N is at 6, negative 2. 6, negative 2. There's N. And O is at 2, negative 4. So we're starting down here now in quadrant 4, where all coordinates are negative. Let me get something that looks like that. There's our first triangle. The first transformation we're going to do again is a dilation, but this time we're going by a scale factor of 1/2. Right? So we're still going to do x times 1/2, comma, y times 1/2 for the rule, but we can think about this one of 2 ways. We could either think of it like we're multiplying each coordinate by 1/2, or if it's easier, we can think about just dividing each of these coordinates by 2. So 10 divided by 2 gives us a new m prime x coordinate of 5. Right? Half of 10 is 5. Well, what's half of negative 8? That would be -4, just like that. So we're dividing by 2. 6 divided by 2 is 3. -2 divided by 2 is -1. 2 divided by 2 is 1. -4 divided by 2 is -2. So those are our 3 new prime points. I'm going to go ahead and graph those real quick. 5, -4 is right there. We're inside our other triangle, but again, that is okay. 3, -1, that's my n prime. There's m prime. And O prime is 1, -2. O prime, just like that. So this triangle, we can see, got a lot smaller than our original triangle. That's because our scale factor was less than 1. It was a fractional scale factor, so our triangle became a fraction of the size. But you'll also notice that the way that our triangle looks hasn't changed at all. Right? We don't now have an equilateral triangle or anything like that. It looks like the same triangle, just looks like its little brother or something. Right? Same exact triangle, just shrunk up. There's our dilation. Now let's go to the reflection. We're going to reflect. This time we're reflecting across the x-axis. So we're going to keep our x-coordinate the same, but we're going to flip the sign of our y-coordinate, right? That's our rule. If you're confused on where I'm getting these rules from, just take a look back at your notes. We have 3 independent lessons: the rule of reflection, rule of translation, and rule of rotation, aside from our printed notes that we have on these specific rules. Again, we're going to pretend our original coordinates don't exist. We're only going to focus on the most recent coordinates. All right? And for this rule, all my x's are going to stay exactly the same. So 5, 3, and 1, we could just write those down: 5, 3, and 1. But all my y values, we're going to flip the sign. We got a -y. So all these negatives, we're going to flip that sign to make them positive. +4, +1, and +2. Now let's graph those. 5, 4, 3, 1, and 1, 2. There's my new triangle right there. And that's number 3. This purple one was number 2. And this pencil one, you can't really see it, but it was number 1. Let me make sure I got these points labeled: N double prime, O double prime, and M double prime up there. There's my reflection. Now let's move on to the translation. Again, a translation is just a slide. So we're not going to turn it. We're not going to flip it. We're just going to slide it. All right? We're going to go 10 units to the left. That'll give us x minus 10 for the rule because the left is negative. And 3 units up, that'll give us y plus 3. Again, when we're going up, that's going to be positive. We had the reverse for both of these up top on number 1. So we're going to take all these x values and we're going to subtract 10. 5 minus 10 is -5. 3 minus 10 is -7. And 1 minus 10 is -9. Then we're going to add 3 to all these y values. 4 plus 3 is 7. 1 plus 3 is 4. 2 plus 3 is 5, just like that. Now we can plot these. -5, 7, -7, 4, and -9, 5. O triple prime, N triple prime, and M triple prime, just like that. I'm not going to use a ruler. I really should have used a ruler. Thought I could have got away with it because it's a small triangle, but guess not. There's my new 4th triangle right there. We translated it left, and then we translated it up. 4th and final move that's going to get us our 5th triangle is rotating 90 degrees. This time we're going counterclockwise, which is to the left like that. So the rule here is going to be -y, x. Again, if you're not sure how I got that, just take a look back at your notes. So how are we going to translate these orange coordinates into our new pink coordinates here? Well, we're going to take our x values, all these negative numbers here in front. We're not going to change them. We're just going to bring them to the back. -5, -7, -9. See how x for our rule is written in the second position of our coordinate pair? That's why we bring all those numbers over here to the right. Now we're going to take these y coordinates and we're going to bring them in front, but we need to flip the sign of them, which in this case is turning them all from negative, or I'm sorry, in this case is turning them all from positives to negatives. -7, -4, -5. And we can plot those. -7, -5, -4, -7, and -5, -9. O quadruple prime, N quadruple prime, and M quadruple prime. I'm actually going to use my ruler this time so that my triangle is nice and straight. Just like that. And there's our fifth triangle. Again, take a look. We've got 1, 2, 3, 4, all 4 quadrants filled up with the triangle. And the quadrant where our dilation took place has 2 triangles in it, just like we saw up on number 1. Again, pause, rewind if need be. I'm moving on to number 3. So in the back, number 3, again, it seems repetitive, but we're going to do the same thing. Now, the order of these is all different, but we're going to do essentially the same process. We're going to start by dilating, this time by a scale factor of 2. So we're going to take x times 2, and we're going to take y times 2. I'm sorry, I totally skipped a step. We got to graph the pre-image first. 1, 5, there's point A. 5, 5, there's point B. And 4, 1, there's point C. Boom. There's my pre-image. We'll call that triangle number 1. Now we're going to dilate this. So we're going to take all these numbers and we're just going to multiply them all by 2. 1, 5 multiplied by 2 gives us 2, 10. 5, 5 multiplied by 2 gives us 10, 10. And 4, 1 turns to 8, 2. We'll go 2, 10. We'll go 10, 10. And we'll go 8, 2. There's C prime, B prime, and A prime. So remember, dilation is the only transformation of the 4 that changes the size of our actual shape, right? Think about your eyes dilating. When your eyes dilate, the pupils shrink up and expand depending on how much light is in the room, right? So in the same way, our shapes are shrinking and expanding based on whatever scale factor we've got going on. Okay? There's triangle number 2. Now we're going to translate. What color was translate? Or no, the second step was green. We're going to translate 1 unit to the left, x minus 1, 11 units down, y minus 11. This time we've got a double negative translation here, and that's totally fine. We're just going to be bringing this new shape, right, our second shape, left and down. Really, we're just going to be bringing it down because we're not moving it to the left that much, but let's do that. 2 minus 1 gives us 1. 10 minus 1 gives us 9. 8 minus 1 gives us 7. Take a look at the y coordinates. 10 minus 11 gives us -1. -1. Now 2 minus 11, that's going to give us -9. Right? So 1 -1, 9 -1, and 7 -9. C double prime, B double prime, A double prime. Remember, with a translation, we're just sliding this figure along our graph. So it should look like it's in the same exact orientation as our previous triangle, but it's in a different position, right? It's located in a different spot, but it looks exactly the same as our purple triangle. Now let's go ahead and rotate it. We're going to rotate it 180 degrees this time, so our rule is going to be -x, -y. So remember, if you have your slide, you can place it over the graph, mark your little plus at the center, dot all 3 of your points, and turn that slide 2 spaces. What I'm going to do is I'm just going to flip all my signs here. right? We're not going back to my previous points. We're just using the most recent points. And we're going to flip all these x's from positives to negative, and all these y's from negatives to positives. Because the rule tells us we got to flip the x and flip the y. So 197 turns to negative 1, negative 9, negative 7. And negative 1, negative 1, negative 9 turns to positive 1, positive 1, positive 9. Negative 1, 9, negative 9, 1, and negative 7, 9. C triple prime, that doesn't look right. Why does that look so wrong? What did I do wrong? Oh, I'm sorry. That point's not supposed to be there. Do I have white out? Oh, yes I do. Sorry, I'm not at class, I'm at home. Okay, I'm going to wipe that out. I meant to do, sorry, negative 1, 1. There we go, right there. That makes a lot more sense and is going to look a lot nicer. Which brings up a really good point going into the test tomorrow, right? If you do a transformation and you see that your triangle has changed its shape, like it looks like a completely different type of triangle, you definitely want to check your work and make sure that something didn't go wrong. Your triangles should always look like they're shaped exactly the same. Even if they shrink or enlarge, even if they flip or rotate, they should look like the same triangle. Hopefully that makes a little sense. Finally, we're going to reflect. This time we're going to go across the x-axis. That's the rule x comma negative y. We're going to take this orange triangle and we're going to flip it now over this pink line, this x-axis. All right, all my x's are going to stay the same. Negative 1, negative 9, negative 7. Those are all the same. But all my y coordinates here are going to flip back to negative. Negative 1, negative 1, negative 9. Negative 1, negative 1's right there. Getting a little messy. Negative 9, negative 1. And negative 7. Oops. Negative 9. There's C, quadruple prime. B, quadruple prime. And right here is A, quadruple prime. It's kind of hard to see because I wrote my A double prime in the way, but hopefully you guys see what I did there. There we go. And that's my fifth triangle. So remember, we started out with this tiny little triangle here. The first thing we did was dilate it and make it larger. Every other triangle after that needs to be that same large size, right? We're doing these in order. Even though we can see all 5 triangles, every time we create a new change, we have to pretend that that previous triangle no longer exists. We're always using the freshest, newest triangle or the freshest, newest set of coordinates when we're going on to the next transformation. Speaking of going on to the next transformation, let's look at number 4. I'm going to plot my pre-image so I don't forget that. Negative 9, 1. There's Q. Negative 5, negative 3. There's R. And negative 9, negative 7. There's S. Now this one dips a little bit out of quadrant 3 up into quadrant 2, but that's okay. Alright, that's totally fine. Let's see what we're going to do. We're going to start, this time we're not going to start with a dilation. This time we're going to do the dilation at the end. So first we're going to translate 3 units to the right and 9 units up. Those are both positive movements, so my rule is going to be x plus 3, y plus 9. And you know what, just for fun, actually no, I'm going to keep doing it with the coordinates because I like those better. Actually, you know what, for the translation, for the translation, I'm going to do it on the graph here. So x plus 3, y plus 9, I'm going to start here at R, I'm going to go 3 to the right, and then from there I'm going to go 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, boom. There's my R prime. It's at negative 2, 6. So I've been starting with the coordinates and then plotting it. If you're more comfortable doing the graph work and then just identifying the coordinate, totally fine with me too. Either way works. Q, we're going to go to the right, 1, 2, 3. And then we're going to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's Q prime. And my S, we're going to go 3 to the right, 1, 2, 3. And we're going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's S prime right there. I'll connect those up. And there's our first image. Pretend that the pencil triangle doesn't exist anymore. We're not going to use that. We're going to use our purple. It's been a long day. We're going to use our purple triangle when we go to the next one. But let me get these points figured out. S prime is at negative 6, 2. And Q prime's at negative 6, 10. And we could have got these points if we took all these X values and added 3. And then took all these Y values and added 9. We would have got the same exact numbers. Here's number 2. This one here was number 1. Now let's do our second transformation to get our third triangle, a reflection across the Y-axis. There's our rule. Here's our axis that we're going to reflect. And we can just count 1, 2 spaces to that line of reflection, 1, 2 spaces past that line of reflection. There's R double prime, which is at 2, 6. Q, we can count over 1, 2, 3, 4, 5, 6 spaces. So we're going to go 1, 2, 3, 4, 5, 6 more spaces on the other side. There's Q double prime at 6, 10. Notice how from Q prime to Q double prime, all I did was flip the sign of my X. Right? Negative 6, 10 became positive 6, 10. So down here, negative 6, 2 is going to become positive 6, 2. Positive 6, 2. S double prime. So mixed a little bit of graph work plus the rule there, just so you can kind of see how they're both related and how, in reality, it's the same exact thing we're doing. Just depends on what type of learner you are, that's all. There's our third triangle, 2 more to go. Let's hit a rotation. 90 degrees clockwise, that's going to be Y, negative X. I don't have my transparent slide, so I'm going to do this one the coordinate way. Take all our Y coordinates, 10, 6, 2. They're going to stay the same, but they're going to be brought in front, 10, 6, 2. All my X values, 6, 2, 6. They're going to get those signs flipped around and stuck on the end. Negative 6, negative 2, negative 6. 10, negative 6 is right there. 6, negative 2 is right there. And 2, negative 6 is right there. So we got S triple, Q triple, R triple prime. Does that look right? Did I do that right? 10, negative... Oh, that's a negative 5. I meant to put my point right there. My bad. Forget about that one. There we go. I thought it looked off. Once again, it's easy to make mistakes. I'm the dang teacher, and I'm making mistakes. So it should be... I should make it clear that you always want to check as you're going. If something doesn't look right, take a step back, look at it from a different perspective, and see what you might need to change. Okay. There's our fourth triangle. We're good on the rotation. Now, in a strange turn of events, we're going to do a dilation last. Scale factor of 1/2. X times 1/2. Y times 1/2. We could also think of this like we're dividing by 2. So take all these coordinates here, these orange ones, and divide them all by 2. 10, negative 6 turns to 5, negative 3. 5, negative 3. 6, negative 2 turns to 3, negative 1. Boom. And 2, negative 6 turns to 1, negative 3. Boom. Plot all those points, connect them up. Make sure they're nice and labeled, which I'll get to in a second once I connect them. Let's see, this was R quadruple prime. Down here at 1, negative 3, that was S quadruple prime, and over here, it's going to be hard to write, but that's Q quadruple prime right there for our fifth triangle. So I know that's a lot, all right? I know it's a lot, but if you take it step by step, using your rules and using your graphing skills, we should be good to go, okay? If you have any last-minute questions about this worksheet, we will have a little bit of time at the beginning of class to go over one or two things, but I want to give you guys plenty of time to get the test done. All right? Hopefully this helps. If you have any questions, let me know in class tomorrow. Thanks for watching.